All right, this is lesson 7.3, proving triangles similar. We're going to learn how to use the angle-angle similarity postulate, the side-angle-side similarity postulate, and the side-side-side similarity theorems. And we're also going to learn how to use similarity to find indirect measurements. So, a couple of review things we may need for this. What the converse is. All right, the converse is. Go ahead and see if you can write those out as the converse, and you can check back for your answer. And answer 3 and 4 also at the bottom of this page. All right, so here's our postulates. 7.1, angle-angle similarity postulate. If two angles of one triangle are congruent to two angles of another triangle, then triangles are similar. Well, that makes sense because if two angles are congruent, then the other one is congruent by the third angle theorem. Side-angle-side similarity. If an angle of one triangle is congruent to an angle of the second triangle, and the sides that include the two angles are proportional, then the triangles are similar. And the side-side-side similarity theorem, if all three sides are proportional to the corresponding sides, then the triangles are similar. So here we have 2 corresponds to 4, and 3 corresponds, which is 1/2, and 3 corresponds to 6, which is also 1/2. And we also know that all right triangles are congruent, so we have that these two triangles are similar by side-angle-side similarity. All right, so let's use some of those ideas here. Are the two triangles similar? How do you know? So in this first one, we have angle R is congruent to angle N, and we have angle S is congruent to angle O because all right angles are congruent. So we have 2 angles that are congruent. That's enough to know that triangle RST is congruent to triangle NOP, and we're going to say by angle-angle similarity. Okay, and the second one, I think we should fill in the missing angle using the sum of the angles of the triangle equals 180. So this is going to equal 60, I believe. And this one here is going to equal, let's see, 85, 95, looks like. 95 and 85, yes. So we have only one angle that's congruent. That's not enough. We're going to say that these are not similar. All right, go ahead, you try it. I'll pause here. You can see what you think. All right, problem 2, are the angles similar? If so, write a similarity statement. We're given all the side lengths, so let's check out the ratio of corresponding sides and see if we get the same number. So the short sides, that would be PL over RK, that would be 5 over 10, that's 1/2. The longer legs, that would be DP over KS, and that's 12 over 24, which is also 1/2. And when we're given the sides, we need all the sides have the same, are proportional, corresponding sides. So we need to check the last one also, and that would be 13 over 26, which is also 1/2. So we're going to say, because we got the same ratio for all sets of corresponding sides, we're going to say that triangle RKS is similar to triangle LPD. And and that's by side, side, side similarity there. Okay, and how about the second one here? We're going to check this by doing, I see two triangles here like this. That one and that one are possibly similar, so we're given side lengths again. So we'll check the corresponding side lengths. We'll go ST over RT, and that's equal to 10 over 14, which is simplified 5/7. Then we're going to do du, or UT, I should say, UT over VT, and that's equal to 12 over 16.8. And if we simplify that, it'd be the same as 120 over 168, but that also simplifies to 5/7. And one other thing we know is that angle T is congruent to angle T, and they both share that angle. So we're going to say that triangle TUS is similar to triangle TBR, and that's by side angle side similarity. Let's show it. All right, go ahead, you try it. I'll pause here. You can check back. All right. Problem 3, proving triangles are similar. Okay, so we're going to use one of those postulates theorems if we can. And just looking at this, we want to try and prove they're similar. And I'm thinking it'd be nice to know what one more angle is, because I don't think we can show that the corresponding sides have equal ratios. But we can say that that this angle here is going to be 55, and this angle here is going to be 35. And so we can say that these are similar by angle similarity. And so to do that, we're just going to write down the steps. First, I'm going to write down my given. Pause while I do that. Okay, so there's my given. Since I have right angles, I probably should say that all right angles are congruent, but I think I'm okay to say that since they're both right angles, they're both equal, and they both equal 90. Definition of right angles. Okay, so now I'm going to write the measure of angle S plus the measure of angle STL plus the measure of angle SLT is equal to 180, and that's the triangle angle sum here. And then I'm just going to substitute my values, 35 for S, 90 for STL, and this one I don't have yet. SLT equals 180, and that's just substitution. Then I'm going to subtract from both sides, and I get the measure of angle SLT equals 55. All right. And now that I have the measure of angle SLT equals 55, I can say that the measure of angle SLT is equal to the measure of angle LTC, and that's by the transitive property of equality. And so now I can say that triangle STL is similar to triangle CLT, and that's by the angle similarity postulate. All right, so I'll let you try it. Just fill in the blanks there. Check back for your answer. You should should have something like that. All right, problem 4. Benjamin places a mirror 40 feet from the base of an oak tree. When he stands at a distance 5 feet from the mirror, he can see the top of the tree in the reflection. If Ben is 5 feet 8 inches tall, what is the height of the oak tree? I'm going to make a drawing to help me get my thinking together here. Okay, so this drawing isn't to scale, but I'll fill in some values. The mirror is right here. In black, so there's the mirror. All right, and from the mirror to the base of the oak tree is 40. From Ben to the mirror is 5 feet. Ben is 5 feet 8 inches tall. Actually, we should know where his eye is, but we're just estimating, so that's probably pretty good. 5 feet 8 inches. All right, and we are trying to find the height of the tree, which we'll just call that H. And so we get two similar triangles like that. We have to assume that the ground is flat for this to work. If it's not flat, then it's just a rough estimate. It's a better estimate if the ground is flat. And we have similar triangles because we got two right angles there. And also our other angles should be the same because we're reflecting in a mirror. Those two should be the same. And if two angles are the same, then the angles at the top of the tree and at the top of the bench then should be the same. So our sides should be proportional. So I'm going to use 5 over 40, because that's the two short sides of the triangle. Then I'm going to use the height of Ben. I'm going to write that as a decimal number, I think. That would be 5.6, repeating if you want, because 8 inches out of 12 is 2/3, which is 0.6 repeating. So, and then the height of the tree will just go there. Then I'm just going to multiply 40 times 5.6 repeating, and that should equal to 5 times 8 using the cross product property. And so if I divide both sides by 5, I get about 45 feet for the tree. All right? Go ahead, you try it here. All right, so you probably should say the ground should be flat so that you have similar triangles, and then you can use the ideas of similar triangles. If you wanted to figure out how high it is, then you could use a proportion like x over 5.5 equals 34 over 6, and then you could use cross products property to solve that. All right, lesson check. What is wrong with the way they did this? You should put in the numbers like this. The solution is crossed out. It does not show the correct value of x because the sides aren't proportional in that way, written the way they were. They're not correctly using the proportions. All right, that's it. See you tomorrow.